In this presentation, I'm going to talk about how we can use knowledge distillation and distill the hidden knowledge inside a cross-encoder into a bi-encoder. In all the modern rack systems, we use bi-encoders or cross-encoders. So let's first talk about what are these bi-encoder models and cross-encoder models. So to retrieve information in the current modern AI pipelines, we use vector-based retrieval methods. Bi-encoder is an encoder where you prepare vector database for all your information, and then later on when user asks any query, you again embed that query and perform retrieval using cosine similarity or dot product into your database. So basically, irrespective of the query, the vector database will remain the same, and this is the weakest part of bi-encoders. Although they are cost efficient because you only need to prepare the vector database once, but they don't see the query. That is where comes the cross-encoder. Cross-encoders are much more accurate than bi-encoders, but obviously there comes the cost factor. You need to feed the raw query and the raw document all together in the architecture, and then you will get the relevance score. So this is really a costly process, because if you want to, let's say, retrieve information from your database using a cross encoder, then you need to feed the entire documents again, and using attention you basically calculate similarity between the documents and the query. Whereas in case of bi-encoders, you already have the vector database, you only need to prepare the vector for the query, so it is cost efficient. So in my project, what I have done is I have picked this Microsoft paper, so you can't find out the full fine-tuning code on GitHub or on any other sources. So what I did in my IBM work, actually I needed to fine-tune E5 for some experiments. So I read the paper, entire E5 paper, and following the paper I built the full fine-tuning code along with the required datasets. So the exact datasets were also not available, so I derived the datasets from DPR. In this project, using KL divergence, I distilled the hidden knowledge inside the cross encoder into the bi-encoder. So there are multiple loss functions. In some methods you can directly utilize the raw logits out of the teacher model and teach your student model. There are other some methods where you can actually produce the probability from the teacher, and you basically teach the base model that you have, the student model, to follow the probability distribution of the teacher. For that purpose I have used KL divergence, basically directly utilizing the probability distribution of the teacher itself. So in knowledge distillation, you need to derive the dataset according to the teacher first. We can say we need to gather the experience of the teacher, or what teacher thinks about the distribution. Then we use the same dataset to teach our student model. That's how the KL divergence knowledge distillation works. This is the custom loss function that was mentioned in the paper. So the same I have used. It's like the better model you choose, the better student can become. For more technical details about this project, you can visit my GitHub. Thank you so much.